So, hello, Holly.
Hi.
Should we start by you introducing yourself, please?
Sure. I'm Holly Krieger. I'm a lecturer here in the Pure Mathematics faculty, as well as fellow and director of studies over at Murray Edwards College.
Okay, and could you tell us how and when did you choose to do mathematics?
When I got this job? No, that's not quite true, but to an extent it is. You know, this is a difficult career, at least up until the point when you have a permanent position, to know whether or not you're going to be able to go all the way and stay in academia. But perhaps more of a reasonable answer is there was a professor when I was an undergraduate who I spoke with a lot about the possibility of going to graduate school and what it would be like to be a mathematician and all of these things. And one of the most important things that he told me, which no one else, even since, has ever been willing to say, is that mathematics is actually a good career. And, you know, you can have it as your career and you don't have to be sort of woken in the middle of the night with passion for mathematics. In fact, you can be a mathematician and that can be your job and you can be successful even if that's the case. And so that made me a bit more interested because, you know, I was never the sort of person who, when I was 2 years old, was sort of dreaming of chalkboards. So once I thought that it was reasonable and could accommodate, you know, other things in my life as well, that was really, I really became interested.
And what's it like being a female mathematician in particular?
Sorry, I should have some reasonable answer to this. I assume it's sort of like being a female in most other aspects of life. Most people are quite reasonable and treat you normally. A few people treat you poorly, but they treat everyone poorly. And then there are a few others where it's not so clear. So leaving that aside, I mean, of course, people will behave in the way that they want to behave, and it's not under your control. But the things that I guess are notable about being a female mathematician is it's just very noticeable that you are very often the strong minority in a room. Or even the converse of that, the other side of that is that you can have a very large impact just by being in a room. So if I go to a seminar and me being there means that some postdoc or graduate student is not the only woman in the room, that makes a big difference for her, right? And so so there's sort of this dual aspect of it, which is that I feel like I can have a lot of impact on other mathematicians and other potential and future mathematicians. But then, of course, there is some negative aspects to it as well.
Mm-hmm. And is there any advice you'd give to a young woman who wants to be a mathematician?
I mean, the main advice I would give, because this career path is so drawn out in some ways, right? I mean, to get through the undergrad and maybe a master's and a PhD and all of that kind of thing, and then a postdoc and so on, is that if you want to get through it, all you have to do is not quit. I mean, there will really be times, this is not unique to women, there will really be times when you want to give up and you feel like you need to give up, and in fact, somehow everyone else is more likely to succeed than you, and all you have to do is work through those times instead of being paralyzed by your own sort of concerns.
And for you personally, what are the joys of doing maths and what are the challenges?
Well, the joys are that, you know, I mean, it's the joy of learning, right? Is that's how I spend a decent portion of at least my research time, is learning these sort of fantastically amazing things that other people have done, or relearning in some cases what I have done in the past. And the fact that most of the conversations I have with my colleagues are so interesting, and, you know, that really each day is sort of unexpected. Some has some unexpected aspect to it. The challenges are mostly the practical matters, right? I mean, there's not that much time in the day, and because you're in this sort of tenuous balance between a job that's not really quite as obviously useful maybe as some other science positions, and your teaching, and all of these things have to be balanced. And so you don't get to spend as much time doing that learning and doing that communicating as you might like. Okay.
And could you explain to somebody who doesn't know anything about it what your area of mathematics is about?
Yeah, of course. So I work in dynamics. Dynamics is the study of long-term behavior of systems. So, for example, I mean, I think probably the most familiar example to most people is thinking about orbits, right, or the solar system. So if you go to sort of school physics or something like this, you learn that there are rules for, okay, if all of the planets are, say, just two, to simplify things, if two gravitational bodies are like this at time 1, then they're like this at time 2, then what happens at time 1,000,000, right? So this is what the question of dynamical systems is asking about, is if I know how to go from step A to step B, then can I, when I repeat that process, say something about the long-term behavior? And I particularly study sort of places where dynamics is chaotic, meaning that any small change in the starting configuration might lead to unpredictable behavior in the long term.
Okay, great. And could you describe one of your favorite mathematical moments, like mathematical experiences?
Sure. So I think probably actually most of these come from teaching for me. I mean, of course, there's this wonderful thing when you solve a problem and you didn't understand it one moment and then suddenly it was also brilliantly clear to you the next moment. But I think this is the funniest when it relates to teaching. So there have been so many things that I thought I understood when I learned them, and then I realized when I was preparing teaching that I didn't actually understand them. And so things like, I mean, to use an analogy that most people would be familiar with, it's like when you first learn the Pythagorean theorem, right, which says that a right triangle has this relationship between the squares of the lengths of the edges. Maybe it's hard to remember, like, okay, wait, if this one is A and this one is B and this one is C, is it A squared plus B squared on one side, or is it A squared plus C squared? Which one is it? But then, of course, if you can draw the picture and put it into the context and you really know the proof, then of course you know which one goes by itself, because it's got to be the longest one, right? And so the true understanding of the problem is sort of takes care of all of the sort of unpleasant notation and memorization, right? And so moments like that for me, where it's like I thought I knew something, but really there was something there that was not quite snapped into place in my head. And then I prepare the lecture for it, or I discuss it with a student, and then I realize, oh, of course, I didn't actually understand this the first time, and now I do. I find that really interesting.
Okay, well, thank you very much.
Yeah, thank you.